Okay, Unit 2, test review, Algebra 2A. Let's do this. Describe. See, that's easy because we don't have to graph it. What does that do? It goes left 2. What does that do? That goes down 4. My A is 1, my B is 1, my C is 2, and my D is -4. Same sort of thing, but a little more. My A is right here, and if A is negative, that goes over the x-axis. The 2 is a vertical stretch, and that is going to move it right 1, and that's going to move it up 5. So those are kind of easy, should be. Identify the vertex. Well, the vertex is going to come from here. That's left 3, so -3, and then up 2. So that'd be -3, 2. Now the axis of symmetry is the vertical line that's going to be x equals some number that cuts it in half. So if I draw a little picture here, this does flip it. So the regular parabola would look like this, but that's going to flip it, so it's going to look like this. But the vertex got moved left 3, up 2, so that'd be right here. And so now it's going to look like this, and like this, kind of, sort of. The axis of symmetry is right there, so that is x equals -3. It has a maximum because it goes up and down, and what is the value of the maximum? It's the highest value of y, so in this case, that point is -3, 2, so it gets up to the height of 2. What's the domain? Well, it keeps getting wider and wider in all directions. So the domain for this one is -infinity all the way to +infinity. The range, how low does it go? You always start with that. So it starts at -infinity. And then how high does it get? Well, that's the same thing as the maximum. So that's 2. And it does get there. So that's important because that's a bracket. And that's it for that one. This one right here, again, drawing a picture will help. That's going to move it right 4. Then that's going to move it down 3. And then this is positive, but it's a 3, so it's a vertical stretch, so it's going to be a little skinnier than normal. And so here comes the vertex. The vertex is 4, -3. That's right there. The axis of symmetry cuts it in half, so that has to be x equals 4. And don't forget the x equals part, because you're showing your understanding that all vertical lines are named x equals. And then does it have a maximum or a minimum? Well, this one goes down and comes up, so this one has a minimum value of -3. Domain, same thing as this one. Even though it's skinny, it does continue getting wider and wider both directions forever and ever, so that's -infinity all the way to infinity. What's the range? Well, the range is also the low point, so it goes from -3 with a bracket because it gets there all the way to infinity because it goes up forever in both directions. Now it says write the equation of each quadratic function. Remember, that's just a fancy way of saying parabola, so don't be thrown by this. And this is another hint in vertex form because parabolas have these things called vertices. Well, we're going to start with this. So we know that the general equation is a x minus h squared plus k. And if they told us the vertex is 2, 1, we know what to do here and we know what to do here. So step 1 is just to use the vertex. So y equals a, right 2 means x minus 2 squared, up 1, straightforward up 1. The point they give us, 0, 4, that means this parabola will go through this. They're telling us let x be 0 and let y be 4, and that's what we're going to do now. We're going to use this information. So y is 4. We're trying to find a. X is 0. And now you just can't screw up your PEMDAS. So I'm going to subtract 1, subtract 1. And I'm going to take care of this. -2 squared is 4. So that's 3 equals 4a. Divide by 4, divide by 4. A is 3/4. And we're going to pop that bad boy right there. So that's y equals 3/4 x minus 2 squared plus 1. And there's our equation of that parabola. Let's try this one. Same thing, less explanation. Number one, we're going to make our adjustments here. This is my x adjustment, this is my y adjustment. So we start with this. Right 1 means minus 1, up 5 means plus 5. Now we're going to use this point that it goes through and plug it in. So negative 1 equals a times x minus 1. We're using that x squared plus 5. I'm going to clean this up. Negative 6. 3 minus 1 is 2. 2 squared is 4. So you get 4a. Divide by 4. Reduce it. And I get negative 3 halves. I'm just going to put that right here and we'll be done. So y equals negative 3 halves x minus 1 squared plus 5. There would be my answer for part number 6. Alright, the graph of a function y equals x squared translated 4 units down, 2 units right. This is where I'm going to start. What is the resulting function of g of x? So we're going to go g of x equals 2 units right just simply means x minus 2 squared, and then 4 units down means minus 4. And they don't say anything about a vertical stretch or anything, so we're done. So the instructions, find the vertex. Remember, we got to put this in vertex form, which looks like this. We talked about this in class. This comes from a perfect square trinomial, and that's where we need to complete the square in order to do so. So, and the y-intercept. Remember, the y-intercept is where x equals 0. So you can find this right away, because if x equals 0 and x equals 0, that would just be y equals 15. So there's our y-intercept, just 0, 15. That's just kind of easy if you can picture it. But now the hard part, we got to complete the square. So this is where we go like this, create a space, we kick that number to the curb, kick it over, and then create another space. Take half of that. See, this has to be a 1, and it is. Take half of that is negative 3. Square it is 9, but if I put a 9 there, I got to put a negative 9 there. Now this is my perfect square trinomial. This is a nice little cheat code, because that perfect square trinomial will factor into x minus 3, x minus 3, but we're not leaving it there. We're going to leave it as x minus 3 squared, because now this looks like that. And then 15 minus 9 is just 6, and that equals our y. Now we can use it to graph the equation. So this moves our vertex right 3 up 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Because there's an invisible 1 right there. It's just normal, and it's happy. Let's go to this one. Remember I said this has to be a 1? Now it's very significant because we look at this. Some of you are going to want to divide this all by negative 2 to make that a 1. You fix this problem, but then you create a problem over here because you got y over negative 2. So that's not a horrible idea. It just doesn't work. So you got to get a little fancy here. Remember, we kicked that to the curb, which means we're going to concentrate here. And if that needs to be a 1, we need to take out whatever's sitting right there. So we're going to factor a negative 2 out of both of these things. That's the key. X squared plus, the reason it's plus is because the negative times the positive gives us what we need, and that's a negative. But if we take a 2 out of 4, a factor of 2 out, we're left with 2x. I'm going to pull a space here, plus 6 plus space. Now this gets a little tricky. Take half of 2, it's 1. Square it, it's 1. Is that a 1? No. It's a 1 times negative 2, so that's negative 2. So we got to balance it by putting a positive 2 there. That's a tricky little moment. Now we're going to factor this thing, negative 2 from here. I'm going to take the cheat, that's just x plus 1 squared plus 8. Now I can graph it. Left 1, up 8. Left 1, 1, 2, 3, 4, 5, 6, 7, up 1 more. This is sad and a little skinny. So make it really skinny. And there you go. Number 9 is done. All right, number 10 is going to require a drawing, so I'm going to draw it, and I'll get back to you in a second, and then we'll read it.